Let's look at another example of an infinite series and determine if it's convergent or divergent. So this is the term sum of n goes from 0 to infinity, sum of this term as n goes from 0 to infinity. So now let's take the limit of this term as n approaches infinity. Limit of this term as n approaches infinity of this term. So n is going from 0 to infinity, right? Let's just actually do the math and see how this term behaves. So this just means n is equals 0. This just means n is equals 0. Don't get confused by this. So n is 0. I'm plugging in 0 here in this term. N is equals 0. I'm plugging in that in. Negative 1 to the power of 0 is 1. Anything to the power of 0 is 1. You know that. And then n equals 1. Negative 1 to the power of 1 is negative 1. N equals 2. Negative 1 to the power of 2. That's negative 1 times negative 1, which is 1. And n equals 3 is equals negative 1 to the power of 3, which is negative 1 times negative 1 times negative 1, which is negative 1. As you can see, as you go from 0 all the way to infinity, it does not matter how far you go. It doesn't matter how far you go. This pattern will keep repeating. It's going to keep going on and on like this. It's going to keep repeating. 1, negative 1, 1, negative 1. Let's say n is equals 4. That's going to be negative 1 to the power of 4. That would be negative 1 times negative 1, positive 1 times negative 1, negative 1 times negative 1 again, positive 1. It's going to be positive 1. It's going to keep going like this. So this is not converging to a certain number. It's not doing that. It's diverging. Like it's not settling for a number. It's going hopping from 1 to negative 1 to 1. So we call this series a divergent or diverging series.